All right, so about 8 years ago, I came back to the faculty, and they asked me to work with the developmental math group. And I said, okay, what is it we're doing? And they gave me that piece of paper. And I knew as an advisor, my career was going to be very short. This was in the middle of a transition, and we were going from 3 credits to 5 credits. Now we've thrown this whole thing out. But just an example, Bruce is always asking me, well, how did students do in this? Well, we haven't seen some of them. You know, they kind of disappeared into that and they haven't come out. But I do have some numbers from the East Central Region or District. There's about 13,000 students that underneath this thing here were active in a year, which meant they took a class in either and or the fall, spring, and summer. So there's about 13,000 of them. The numbers that IR, Institutional Research, came up with was 29% of them had not completed their math. That's 3,747 students. Now, and that didn't include the ones that were there just the first semester. That was 20 credits or more. So there were 1,000 students that were between 20 and 29 credits that had not completed their math. There were 700 students between 30 and 39 that had not completed their math. Now we're going the right direction, right? There were 2,000 students that had more than 40 credit hours that had not completed their math. Now, how are you going to get, complete college? It's not going to happen. So, an individual student, about the only one I know that got through all this, is a nursing student. I'm going to call Amanda, and she took Math 015 from me one semester. She took Math 035 twice. I think she got hung up in English or chemistry or something else. Finally got into the nursing program last summer. In the first week of the nursing program's over, it's Friday, she stops by the office, everything's going great. By Sunday afternoon, she's used up all of her family support. Her fiance says her and her 3 kids have to get out, Sunday afternoon. So I got the message. We started trying to line up some of the shelters in town to try to fix it or to find a place for her, and called back a couple hours and said everything was good. And she completed the fall with about a 3.0, the spring with about a 2.8. She got into the graduation because she only had 7 credits left in the summer, so she walked. 2 days after graduation, she got a note from financial aid that said she'd exceeded her maximum time frame. And although she'd saved Pell money, she had a loan set up, she couldn't access any of it. Mary Austria and the college has set up a degree completion thing, 4 students in that case, and after a couple hoops, she was able to get her money, and today she's in clinicals, and she's changed her job now from being a child care worker to a patient care technician in the hospital she hopes to work at. So, but it just puts so much time and distance in when people start and where they want to go. And it didn't take very much of that to figure out we had to change it. That's where we started. We ended up here, or that's where we were last year. We've made some changes, continue to fine tune it. But we've got 3 pathways. The top one's really the college level algebra course, the COREC, quantitative reasoning is the second one. And then what I want to talk about today is the applied technical mathematics. And that's a non-transfer. It's Associate of Applied Science Technical Certificates. It's all the guys that work with their hands. Carrie and Tova went through every one of this is a large college, about 200,000 students a year. Tons of programs, tons of people in every one of 14 districts. And Carrie and Tova did the yeoman's work because they met with every program committee with the math competencies and said, what is it your students actually need? Do they need to do, was it radicals? I don't know what a radical, imaginary numbers, that's a good one. The square root of a negative number is imaginary. Anyway, so the ones that we're going to talk about are the technical pathways. It serves about 14% of the students. It's a little smaller number of the programs. Most of the quantitative reasoning came this way, and then the algebra over that direction. Okay, we've got a group of folks together in December of 2013. We sat down and worked for a couple days to figure out what competencies the technology folks needed based on the work of Tova and Carrie, and we came up with 5 modules. We came up with a mathematics review because when people come in, they haven't used fractions, they haven't done a lot of percentages and rates, ratios, and they really need that to move on. So we did put a little bit of review in there, and we've since reduced that. Algebra section, equations, not only plug and chug, but trying to be able to find equations that specifically work with HVAC or how thick a bead has to be for a V in a certain cut in a weld. And then plane and solid figure geometry. These guys here are doing some solid figure geometry. They're doing a cone or a pyramid. And then trig, and then statistics. So these were the 5 areas. What we did was we had one class, we won't call it a pilot stand, but we had one class in Muncie, Indiana, and the teams that were working on this, 8 different groups around the state, came in and taught a class on a given topic in the fall semester 2013. And then they evaluated themselves, and the 11 students that were in that class evaluated them and told them what worked and what didn't work. So we took all of those notes, we took all the competencies, and we sat down at the end of that semester and we wrote the course the first time. Through the spring semester, we branched it out to 5 different regions. We went from 11 students to 49. We had faculty then talking after every module to continue to revise the course. We had a bank of test questions. We all used the same tests or similar tests so we could do comparison of competency versus item analysis. And then we got down to the final end of the semester, we rewrote it again. We rewrote it again in August of last year. We rewrote it again in the fall of 2014. And we did a rewrite just about 5 weeks ago at the end of this semester. So it's continually evolving, continually working. Part of the process to set this up was we took a look at where the students were, and we took a look at where they needed to go in terms of scaling up. For the quantitative reasoning, we figured out we needed 450 more sections of quantitative reasoning than we did 118. We needed about 250 new sections of the tech math course than we'd had before. And so we had to figure out, first of all, do we have the capacity to do that? We surveyed faculty credentials. We then set up a professional development program where faculty could go to the university. Dr. Austria helped us with that, to take classes, to get the 18 credit hours or whatever it was that they needed to fill in. And we started recruiting a different group of faculty to teach both the QR and the tech math. We looked at the resources, we looked at the revenues, we looked at the rooms. In terms of scaling it up across the state of Indiana, we looked at everything we could, and we're pretty much along the way. The class we've got right now has got about 800 students in it. We expect about 4,000 across the year when we get into it. The best practices for the tech math class are hands-on inquiry. It's math examples with a high correlation to technical areas. Use of my math lab early on in that first review period because everybody comes in at a different place. They work through the my math lab to get them to the same place before they start algebra. Once algebra, we're at midterm, and we find whatever their midterm grade is, we're about 3% lower that for the final grade. So if we can get them through the review and the algebra, the geometry, the trig, and the stats comes pretty easy. Organization, we initially scripted it. Faculty were involved in that. You have to be pretty thick-skinned to put something 300 pages together and see it ripped apart. But these are the folks that you can't gear it up yourself. You can't scale it up. You've got to have other people on the team, and if they're involved in every step along the way, those 5 became 14. Those 14 now are up to about 40. Our best ally in the whole thing is the technology faculty, because they said this is so much better for their students than algebra or the 118 course. Regular conference calls, face-to-face discussion, Blackboard site for organization, everything's out there. The results in the fall of 2014, 78% of 787 students got a D or better. 69% got a C or better. Compared to 40% in the 118, if they were in the college algebra, it was down to the 20s. In the spring, we dropped a little bit. 74% of 808 students passed the course. Now, we do data on everything, and we know every one of those students from the fall, and we know that 60% of that 122 that didn't pass, if you cut it one way, they have a GPA at the end of the semester of 1.5 or less. If you cut it a little different way, they were withdrawn or they didn't show up for the final. So now that becomes something that may be involved in the class, but we think it involves a little more too with some of our support services. So we're in the process now of, as soon as we get the report from the fall this week, or from the spring this week, we're going to call all the students out of that 808 that flunked, didn't show up, find out why, and then see if we can have some very specific things to help them out. Dr. Ostry doesn't think I can get to 100%, but I think I'm going to try to get at least 85 or 90. What do we still need to do? We still need to scale it up some more to 4,000 students approximately. We need to continue the process of reviewing and revising based on the data. It's really telling to see the questions they missed on the tests. And you know, when 45, 50, 60% of your students miss a question, is a question relevant? Is it something we need to be doing? Is there a better way to do it? Is there something with hands-on that they can explore that will lead them to the higher level math thinking involved? Developing training videos for the faculty. If we go from about 80 sections, 35 to 40 sections in the last 2 semesters up to a couple hundred, we're going to need some more faculty. We're developing videos to help train those folks. So when they get the class assignment Sunday night and they're teaching it Monday, they'll know what they're supposed to be doing. Survey the failing students for patterns, engage student support services for failing students, and that's where we're headed. As an example, this is trig. Have you ever tried to figure out Pythagorean theorem in a textbook when the drawing's an inch? And you measure it and you're off by 10%, it really throws off your numbers. But if you draw it out about 30 inches by 24 and you start doing a squared plus b squared equals c squared, it comes a lot closer. They can see it. They move from that to measuring whether doors are square in the building and working with that. But it's been real exciting. I don't think I've ever been involved in anything as important as the math project in Indiana. We've had great system leadership. We've had great participation with faculty, and really our allies in the process are the technology faculty whose students go back and say, we had a great time in math today, which, you know, doesn't happen very often.